So some flat maps are projected and then displayed in a Cartesian coordinate system. The Cartesian coordinate system is simply an XY coordinate system, like a piece of graph paper, and those red arrows on the left, in the lower left, are meant to display that. X changes as we move from right to left across the map, or from left to right, and Y changes as we move from the bottom of the map towards the top of the map. This map is a plate carré map projection in which the geographic coordinates of the Earth were made flat by saying that latitude is going to vary with the Y coordinate and longitude is going to vary with the X coordinate, and all of those changes are going to be equally spaced on this flat piece of paper. What we can see is, if we do this, is we don't get an unreasonable looking map, but there is a lot of distortion associated with this map. While lines of longitude don't change in length, so that all of the up and down lines on this map have not as much distortion associated with them, the lines of latitude change significantly. Once again, the longest line of latitude would be the one that goes around the Earth at the equator. It's going to be equal to the entire circumference of the Earth. But the lines of latitude as we move towards the North Pole and the South Pole become shorter and shorter. And that's really not accounted for in this map projection. We can see that the area of Antarctica near the South Pole looks huge on this map. It looks bigger than any of the other continents, which is not true. It's not as much of an effect at the northernmost latitudes, getting closer to the North Pole, because there's no landmass right at the North Pole, but we can see Greenland, which is a little off to the northeast of the United States and Canada. That's shown as much bigger than it really is in the real world. Of course, when we talk about Cartesian coordinate systems, we're not always looking at a world map. We could be looking at a 2D Cartesian coordinate system for a very localized area, and this would be after we put it in some sort of map projection. These can be quite useful because we talk more about moving in the X or the east-west direction and the Y or the north-south direction. So it helps us to navigate with a compass, for example. So Cartesian coordinate systems are often used on these maps of smaller areas, and they can be quite useful once we get them in a proper map projection. So if we're trying to go from the geographic coordinate systems of the Earth down to a Cartesian coordinate systems, we have to be aware of some facts. First of all, we're trying to make a flat map, but we're starting out with a curved Earth. And because of that, no matter what we do, there is going to be some distortion associated with it. Also, we're just approximating the shape of the Earth when we put points onto even in geographic coordinate systems. We're giving them a latitude and longitude, but we're doing that on an ellipsoid, which is meant to represent the surface of the Earth, but is not exactly the same as the surface of the Earth. If we're measuring distances on the ground with a compass and some sort of measuring devices, there could be errors associated with our measurement. And lastly, also, the Earth changes over time. With plate tectonics, there's actually motions on the surface of the Earth which displace one feature of the land with respect to other features of the land. So there's also that sort of change that occurs when we try to map in either the Cartesian coordinate systems or the geographic coordinate systems in that case.